Why did we stop burying charcoal in our garden soil? Ancient farmers in the Amazon discovered that a single layer of charcoal buried underground keeps soil rich for over 2,000 years. Modern agriculture replaced it with fertilizer bags you buy every spring. The charcoal they buried is still feeding plants today. This is not a theory. It is not a claim from a gardening blog. It is a discovery made by archaeologists who spent decades trying to explain why specific patches of soil in the Amazon basin outperform everything around them. The surrounding jungle soil is notoriously poor, shallow, and unable to support intensive agriculture for more than a few seasons before it is exhausted. But scattered across the Amazon, researchers kept finding islands of deep, dark, impossibly rich soil that had been supporting dense human settlements for over 2,000 years. Soil so productive that Brazilian farmers today pay premium prices for land that happens to sit on top of it. They call it Terra, Preta, black earth. The secret buried inside it is charcoal. Two things explain why modern agriculture abandoned a soil amendment that ancient Amazonian farmers used to build one of the most productive agricultural systems in the ancient world. One involves what charcoal actually does underground that fertilizer cannot replicate. The other involves who makes money every time you buy a bag instead of burning a pile of wood. By the end of this video, you will understand exactly what Terra Preta is, why the charcoal buried 2,000 years ago is still feeding plants today while your spring fertilizer is gone before summer ends, and how to replicate the same system in your own garden for almost nothing. The Amazon is not supposed to support large, stable civilizations. Tropical jungle soil looks lush because of the canopy above it, but the soil itself is typically thin, acidic, and depleted. The intense rainfall that feeds the forest canopy simultaneously washes nutrients out of the soil faster than most crops can absorb them. When pre-Columbian explorers first described seeing dense, thriving settlements along the Amazon, those reports were dismissed for centuries because the conventional understanding of Amazon soil made large settlements seem impossible. The soil simply could not have supported the populations described. Spanish explorer Francisco de Orellana sailed the Amazon in 1542 and described settlements so large and so continuous along the riverbanks that his crew thought they were sailing past one unbroken city. His account was dismissed as exaggeration for 400 years, because archaeologists believed the poor Amazonian soil could not have fed the population he described. They were looking at the wrong layer of the problem. The population was not surviving despite the soil. The population had transformed the soil. Then archaeologists started testing the soil in the locations those settlements were described. What they found changed the understanding of pre-Columbian civilization in South America and rewrote what scientists believed was possible for soil management in tropical environments. Beneath the sites of ancient settlements were deposits of a distinctly different soil, darker, deeper, richer. In some sites, extending down more than 2 meters, containing charcoal fragments that carbon dating placed at between 500 and 2,500 years old, containing pottery shards, bone fragments, and organic material in densities that indicated deliberate addition rather than natural accumulation. This soil had been made. Ancient farmers in the Amazon had, over generations, deliberately built and improved the ground they farmed. And the primary ingredient in what they built was charcoal. Stay with me, because the chemistry of why charcoal stays active in soil for 2,000 years while commercial fertilizer is gone within weeks is the part that no fertilizer company wants you to understand. When you add a bag of nitrogen fertilizer to your garden, you are adding a soluble compound that dissolves in soil water, is taken up by plant roots over the following weeks, and then is either consumed by the plant or washed out of the soil by rain. In a typical home garden with average rainfall, a significant portion of applied nitrogen fertilizer washes out of the root zone within a single growing season. Studies on nitrogen leaching from fertilized garden and farm soil consistently find that between 20 and 50% of applied nitrogen ends up in groundwater rather than in plants, depending on soil type, rainfall, and application timing. This is why you add fertilizer every spring. It does not stay. It cannot stay because it has no structure to hold it in place. It dissolves, the plant takes what it can reach in the window before the next rain, and the rest is gone. Charcoal is structurally different from any soluble amendment in a way that completely changes this equation. Charcoal is not a nutrient. It is a structure. When wood or organic material is burned at high temperature with limited oxygen, a process called pyrolysis, the organic matter is converted into a stable carbon structure riddled with an enormous number of microscopic pores. A single gram of biochar, the modern term for this deliberately produced agricultural charcoal, can contain a surface area measured in hundreds of square meters when you account for every microscopic pore and channel within its structure. Those pores do not dissolve. They do not wash away. They sit in the soil essentially unchanged for centuries, and they become habitat. Picture what that means at the scale of a garden bed. Every handful of biochar you work into the soil is adding a sponge of microscopic caverns, each one a potential home for a colony of soil bacteria. each one a surface where fungal hyphae can anchor and grow. Each one a reservoir that holds water and dissolved nutrients against the pull of rain and gravity that would otherwise wash those nutrients out of reach. The total surface area added to your soil by a single bag of biochar is greater than the total surface area of the soil particles already in the bed. You are not amending the soil, you are multiplying it. Soil microorganisms, bacteria, fungi, the entire microscopic ecosystem that makes nutrients available to plant roots, need surfaces to live on. In depleted soil, there is not enough surface area in the soil structure itself to support dense microbial populations. The nutrients that fertilizer adds to the soil cannot be fully processed and delivered to plant roots without that microbial infrastructure. Add biochar to soil, and you are not adding nutrients. You are adding habitat. Millions of tiny caverns that beneficial microorganisms colonize and use as permanent base camps from which to process organic matter into plant food. Once colonized, that habitat stays active. It does not wash away with the next rainstorm. It does not decompose. It persists, and the microbial communities living in it persist with it. This is why the charcoal the Amazon farmers buried 2,000 years ago is still productive. They were not adding a fertilizer that would exhaust itself. They were building soil infrastructure that improves with time rather than degrading with use. Here is where modern agriculture falls apart completely. A bag of slow-release fertilizer retails for $40 and is designed to feed plants through one growing season. The manufacturers who produce it are explicit about this design, because a product that required only one purchase would not generate the annual revenue that the agricultural input industry depends on. The entire economic model of modern soil amendment is built around a product that leaves your soil exactly as dependent on the next purchase as it was before the last one. You add fertilizer, the plants use it. The rain washes the rest away. You come back next spring and buy more, the company sells more. Nothing about your soil has fundamentally changed. Consider how aggressively this model has been promoted. University agricultural extension programs across the country, largely funded by relationships with fertilizer manufacturers, teach soil fertility management almost entirely through the lens of annual inputs. Test your soil, identify deficiencies, apply targeted amendment, test again next year. The implicit assumption underlying every piece of advice in that system is that soil health is a problem requiring a recurring purchased solution, not a structural condition that can be permanently improved. A generation of home gardeners has been taught to think about soil the way a drug company wants patients to think about chronic conditions, as something to be managed indefinitely through ongoing product purchases, rather than cured through a one-time intervention. Biochar does the opposite. Add biochar to your soil, and you are making a one-time investment in soil infrastructure that pays dividends for decades, and potentially for generations after you're no longer gardening that plot. The charcoal you bury this spring will still be improving your soil 20 years from now, hosting microbial communities that process organic matter and deliver nutrients to your plants without any annual purchase. A bag of biochar applied once to a garden bed has a longer productive life than any living gardener will be around to measure. The Brazilian farmers, who pay premium prices for land sitting on ancient Terra Preta, deposits are essentially buying the benefit of an agricultural decision made 2,000 years ago. That is what a real soil amendment looks like. It is not a product you consume annually. It is a structural improvement that compounds over time. Now, here's what the science confirms when researchers test these ancient soils against untreated Amazon soil directly. Studies comparing Terra Preta soils to adjacent untreated Amazon soils have found that the black earth contains 3 times the organic matter, higher concentrations of nitrogen, phosphorus, potassium, and calcium, and dramatically higher microbial diversity and activity. Plants grown in Terra Preta without any additional fertilizer consistently outperform plants in treated conventional soil. Researchers have noted that the Terra Preta effect does not fade over decades of continued use the way conventional farming exhausts soil. It improves. The soil biology that charcoal supports continues to build organic matter in soil structure as long as the charcoal matrix remains. What makes these research findings particularly striking is the baseline they are being compared against. Amazon soil is among the most challenging agricultural soil on the planet. If biochar can transform that soil into the most productive agricultural ground in its region, and maintain that productivity for 2,000 years without additional inputs, the implications for gardeners working with difficult or exhausted soil closer to home are significant. The mechanism does not care whether the starting soil is tropical jungle clay or compacted suburban clay. The biochar provides habitat. The habitat supports biology. The biology processes organic matter. The plants eat. The charcoal stays. The cycle continues with or without any annual purchase. Researcher Bruno Glaser, who has studied Terra Preta extensively, has described biochar as a strategy for long-term soil fertility management that has no equivalent in modern agricultural chemistry. Johannes Lehmann at Cornell University, one of the most widely cited researchers in biochar science, has documented charcoal stability in soil lasting thousands of years, and published work on biochar's role in carbon sequestration, significant enough to influence climate modeling at the national scale. A 2006 paper in the journal Nature surveyed the distribution and properties of Terra Preta soils and concluded that the agricultural model they represent, soil improvement through stable carbon structures rather than soluble inputs, deserves serious consideration as an alternative to the nutrient cycling model that modern agriculture is built around. This is peer-reviewed science published in journals that have no financial relationship with the fertilizer industry. Here is exactly how to replicate what the Amazon farmers built, using material you likely produce as a byproduct of normal yard activity. The charcoal you need is not the briquettes sold for barbecue grills. Those contain binders, accelerants, and chemical additives that are harmful to soil biology. You need clean wood char produced from plain, untreated wood burned under low oxygen conditions. This can be produced in a simple backyard kiln made from a metal barrel with a tight lid and a small air intake at the base, or by using the retort method with 2 nested metal containers that allows wood to pyrolyze without fully burning. If you already have a wood fire pit or fireplace that burns untreated wood, the charcoal that remains after the fire is appropriate. Many farms and homesteads produce significant quantities of biochar as a byproduct of burning branches and woody debris. If you cannot produce your own, commercial biochar is available from agricultural suppliers at a fraction of the cost of commercial fertilizers on a per-application basis, because you apply it once rather than annually. The single most important preparation step before adding charcoal to soil is charging it. Raw, uncharged biochar applied to soil will initially draw nutrients into its empty pores rather than releasing them, causing a temporary reduction in plant available nutrients, the opposite of what you want. Charge the biochar first by soaking it for several days in compost tea, by mixing it thoroughly into an active compost pile and leaving it for several weeks before application, or by covering it with diluted liquid fertilizer and allowing it to absorb before use. Charged biochar arrives in your soil already colonized with beneficial microorganisms and already loaded with nutrients stored in its pore structure, ready to exchange those nutrients with plant roots and to host new microbial colonies immediately on contact with your existing soil biology. Apply charged biochar at a rate of roughly 1 to 2 pounds per square foot of garden bed, worked into the top 6 to 12 inches of soil using a fork or tiller. This is a one-time application. You do not repeat it annually. You do not need to reapply in subsequent seasons. The charcoal does not degrade or wash away. It is building soil infrastructure that will outlast your garden. And if you're gardening in the same location for years, it will visibly improve your soil color and texture season by season as organic matter accumulates within its structure. Combine the biochar application with a layer of organic mulch applied to the soil surface, and you have recreated the core of what ancient Amazonian farmers built. The mulch provides continuous organic matter that the microbial community in the biochar matrix will process into plant food. The biochar provides the stable habitat that keeps that microbial community dense and active through drought, rain, and temperature swings that collapse microbial populations in unstructured soil. The plants growing in that system will outperform plants growing in annually fertilized conventional beds within 1 to 2 seasons. And the performance gap will widen every year as the biochar matrix matures and the soil biology it hosts becomes more established and diverse. The fertilizer industry sells you a product designed to leave your soil exactly as dependent as it was before you applied it. Ancient Amazonian farmers built soil that fed their communities for 2,000 years and is still productive today. The difference between those two outcomes is not technology. It is not scale. It is not the centuries of scientific research that separates ancient farmers from modern ones. It is the understanding that soil fertility is a structural condition, not a nutrient deficiency that needs to be corrected with a purchased soluble compound every 12 months. Nobody is selling you biochar in a $40 a bag product pushed at every garden center from March through June. Because biochar, applied once and correctly to your soil, removes you from the annual purchasing cycle for the entire productive lifetime of your garden. The materials to make it are in your yard right now in the form of branches, fallen wood, and any untreated timber that would otherwise be burned or discarded. The knowledge of how to apply it has been sitting in peer-reviewed scientific literature since the early 2000s, when researchers finally understood what they were looking at in the Amazon soil. The ancient farmers who built Terra Preta did not have access to that scientific literature. They had something more useful. They had observation, patience, and time. And what they observed across generations was that burying charcoal made their soil permanently better. And what time taught them was that better soil fed more people more reliably and more sustainably than any other single intervention they could make. The charcoal they buried is still there in the Amazon soil right now. The soil they built around it is still productive today, 2,000 years later with no additional inputs. The fertilizer company that sold your neighbor the $40 bag this spring will need another sale from them next spring, The Amazon farmers needed one decision, made once, that fed their descendants for 2,000 years. If you found this genuinely useful, watch the next video and do not forget to subscribe. See you in the next one.